Hello everyone, in this video we will prove the statement of Cauchy's second theorem and discuss related questions. So the statement of Cauchy's second theorem is let xn be a sequence of positive real numbers, and if the limit of former sequence exists, then limit of later sequence also exists and is equal to L. That is, if limit of xn plus 1 by xn is L, then limit of xn raised to power 1 by n is also L. So first we will recall the definition that if sequence an converges to L, so if limit of an is equal to L, this means for given any epsilon there exists a natural number such that absolute difference of xn minus L is less than epsilon for all n greater than equal to m. So we will assume that this limit exists. So if limit of xn plus 1 by an is L, this implies for any epsilon there exists a natural number such that an minus L is less than epsilon. By opening up the absolute, we will obtain inequality 2, and inequality 2 holds for all natural number which are greater than equal to m. M is a natural number, so m plus 1 is also greater than m. This implies this inequality hold for m plus 1, this inequality also hold for m plus 2, and so on. This inequality will hold for at n also, which is greater than m. So how many inequality we will get? We will get n minus m plus 1 plus 1 inequalities. So n minus m minus 1 plus 1. So we will get n minus m inequalities. So if this inequality hold for m plus 1, how will it look? It will look like L minus epsilon less than equal to x m plus 1 by xm less than L plus epsilon. Similarly, if this inequality hold for m plus 2, then how will it look like? It will look like L minus epsilon less than x m plus 2 divided by x m plus 1 less than L plus epsilon. Similarly, we can write up to n, and when we multiply all these inequality, we will get? We will get L. How many inequalities are these are how many inequalities are there? We have total n minus m inequalities, so we will get, when we multiply these, we will get L minus epsilon raised to power n minus m less than equal to, and by mistakenly I write here 1, so it would be this. When we multiply all these, what we get? We obtain these inequalities basically. Now we will raise this inequality by power 1 by n, so we will obtain this inequality. Now we know that xm raised to power n, since xm is a fixed number of sequence xm, we know that when the limit of xn plus 1 by xn exists, then there exists a natural number m. So corresponding to each epsilon there exists a fixed m. So xm is a fixed number, positive number, so we can multiply this inequality throughout. So we will get xm raised to power 1 by n, L minus epsilon raised to power this, and take limit as n tends to infinity. Now we will calculate this limit. Now as n tends to infinity, 1 by n tends to 0, so xm raised to power 0 is 1. Similarly, when n tends to infinity, this term tends to 1, so right hand side converges to L minus epsilon. Similarly, left hand side converges to L minus epsilon. Similarly, right hand side also converges to L plus epsilon. Now from this we get that limit of xn raised to power 1 by n is L, since we know that epsilon is very small quantity as epsilon tends to 0. So by sandwich theorem, limit of xn raised to power 1 by n is 0. Now with the help of this Cauchy second theorem, we will discuss the question. So first question is n factorial raised to power n by n. So how we will utilize this theorem? Basically we will use a trick. We can write n as n raised to power n into 1 by n. So what would be it? N factorial by n raised to power n and whole raised to power 1 by n. Now we know that if limit of xn plus 1 by xn is L, then limit of this is also L. So instead of this, we will calculate the limit of an plus 1 by an. So we can write xn as an raised to power 1 by n, and an, now instead of an we will calculate limit of an plus 1 by an. So by simplification we will get that limit of this is 1 by e. So we know that if limit of this sequence is 1 by e, then limit of xn is also e. Similarly, for the second question is n by n plus 1 into n plus 2 up to 2n raised to power n. Similarly, the same trick as we use in first question we will use here. So we can write n as n raised to power n into 1 by n. So for the limit, again we can write xn as n raised to power n into 1 by n, and when we rewrite it we will get an raised to power 1 by n. So now instead of calculating the limit of this sequence, we will calculate the sequence of an plus 1 by an. So first we calculate an plus 1, then limit of an plus 1 by an. After simplification, we will get that limit of an plus 1 by an is e by 4. So this implies limit of an plus 1 an by 1 by n is also e. So limit of xn is also e by 4. So similarly, we will solve question number 3. Again, we use the same trick. We can write n as n raised to power n into 1 by n. So we can write xn as an raised to power 1 by n. So now calculating the limit. Now if we have to calculate the limit of an raised to power n, so by the use of Cauchy second theorem, we will calculate again limit of an plus 1 by an. If its limit is finite and exists, so we can say that limit of an raised to power 1 by n also exists and same limit. So thank you.